to your very first Algebra 1 video for the 2016-2017 school year. We're going to jump right into the math, but before we got started, I just wanted to introduce myself in case you're not in my classes. I'm Miss Blaylock, and Mr. Thomas Wick and I are going to be making these videos together throughout the year. So, welcome guys, and let's go ahead and get started. As we're going through the notes in each video, notice that to the left of your notes that you should be filling in, as well as to the left of your practice, there is an area for you to write your questions. So if you have a question about something that I or Mr. Thomas Wick says inside of a video that you want clarification on, but you don't necessarily want to stop right there, or we're busy talking to somebody else, then jot it down over here. And then when we have a chance to come talk to you, you'll remember what it is you needed to ask. Alright guys, you should have your Unit 1 packet out in front of you. And before we get into the first lesson, we're going to take a look at the glossary and define any words that are going to be needed for this lesson. So the glossary is on page 2, and the only word we're really going to talk about today is this very first one, algebra. I figured it was important for you to know what it is we're going to be studying before we really get into the course. So algebra is a branch of mathematics in which symbols, usually but not always letters, are used to represent unknown values and are combined according to the rules of arithmetic. All that means is that we're going to add, subtract, multiply, and divide those symbols the same way we would if they were actually numbers. So go ahead and pause the video now and get this definition copied down into your glossary. All right, you should have that definition down, and let's go ahead and turn to page 3, and you should be looking at lesson 1.1. We are today going to talk about metric to metric unit analysis, and all that means is that we're going to be converting units from one unit to another within that metric system. So the metric system of measurement, there is only one unit of measure for each type of quantity, which is different from what we use in America most of the time, and that is very helpful in working with units with the metric system. So the base unit for length is the meter. The base unit for mass is a gram, G-R-A-M, sorry about my handwriting, and the base unit for volume is a liter, L-I-T-E-R. Okay? In the metric system, we use prefixes to represent values getting smaller or larger than that base quantity. So a meter is the base length, but if you have something that's really, really tiny, then you don't want to use a meter because you're going to have a small fraction or decimal. So that's where we use these prefixes. You've probably seen this before, but let's go ahead and look at what some of these commonly used prefixes are. Uh-oh, scrolled down too far. Some of these common prefixes are, we've got kilo, K-I-L-O, is 1,000 times as big as the base. So if you're talking about lengths, it'll be kilometers. If you're talking about mass, it'll be kilograms. If you're talking about volume, it'll be kiloliters. Use the same prefix no matter what kind of measurement you're talking about. If you've only got 100 times the base, then that is going to be hecto, H-E-C-T-O. And if you've got 10 times the base, then we use deca, D-E-K-A. And same thing as with kilo, it would be decameters for length, decagrams for mass, and decaliters for volume. If you're looking at something smaller than your base unit, 1/10 of the size of your base unit is deci. Oh, got a random little line there. Let me erase that. Well, I'd like to. Okay, whoops. That was deca. Smaller, 1/10 of it smaller is decimeters or decigrams or deciliters. Hundredths, you've probably heard this one, that is the centa. So a centimeter is smaller, is 100th of the size of a meter. And then the last one that we're going to talk about today is milli. So milliliters, milligrams, and millimeters. And again, you've probably heard those before, especially in science class. So there's a couple different ways that you can go about converting between metric units, but the easiest way is just to kind of have the list of your units over here. So kilo, hecto, deca, and then you've got meters, grams, liters, your base units, and then deci, centa, and milli. And you can kind of move up and down this stair system as needed. So if we're starting with 2.5 centimeters, then that means I am right here on my stairs at 2.5. This problem is asking me to go up to meters. Well, if I've got 2.5 centimeters and meters are larger, then my value, the amount, is actually going to get smaller. So as I go up to decimeters, that decimal place would move over one space, so I would end up with 25 hundredths. And then to go up to meters, I'm going to move it one more, so then I end up with 25 thousandths. So my answer is 25 thousandths of a meter. Okay, let's try it from the other direction, and I'm actually going to change my pen color here just so that it doesn't get confusing, because I'm still going to use the same stair. So how many meters are in 4/10 of a kilometer? So I'm starting up here at kilo, and we'll go on the top here. I'm starting up here at 4/10 of a kilometer. This time I'm going down the stairs to meters. Well, kilometers are really, really long. A kilometer is kind of comparable to what we would think of as a mile. And I'm going all the way down to a meter, which is more comparable to a yard. So there are a bunch of yards in a mile. So that means as I go down, I'm now going to be moving that decimal over this way. So I'm going to have 4 hectometers, 40 decameters, because I'm moving that decimal place one more time, and then I'm going to move the decimal place one more time here and get 400 meters. So there are 400 meters in 0.4 kilometers. If you're using the ladder here, then going down the stairs, your value is going to get larger, which means you're moving that decimal one space to the right each step you go down. And if you're going up the stairs, then you're going to move your decimal one space to the left each time you go up. Another option for converting between units is to use multiplication of ratios. But in order to do this, you have to know the conversion factor. Again, sorry about my bad handwriting. Okay, so let's go to the next page and we will talk about how to use conversion factors. We're going to use the conversion factors with converting between times. When you are converting between units with a conversion factor, you're going to use ratios. Oops, and you got a freebie there, a little blank that was already filled in. You're going to use ratios to set up to help you decide whether you need to be multiplying or dividing. But basically, the way we're going to set up these ratios is you're going to be multiplying every time. It's just a matter of whether the value is going to be in the numerator or in the denominator. So what they want to know is how many days are in 15 years. So you're going to start out, your first ratio is going to be 15 years, and we just put it over a 1 because we're going to end up multiplying by some other fraction, so it's easier if you put a 1 there. We want to look up into our conversion factors that we've got up here and see, do we have one that compares days to years? Luckily we do, right here. So I'm going to put what I want days, so 365 days, over what I've got, which is my year. So 365 days is equal to 1 year. The reason it's important that you set up the ratio that way is because now when I multiply across, I have years in the numerator and years in the denominator, and they cancel each other out basically anything divided by itself gives you 1. A year divided by a year, that's gone. That's a 1 now. Okay, so now all I have is 15 times 365, which you can put in your calculator, and it ends up giving you 5,475, and the only units left are days. On the bottom of the fraction, or in the denominator, you have 1 times 1, which is just 1, and 5,475 over 1 is just 5,475. So really, you can say that your answer is 5,475 days. Okay? If you didn't have a conversion that went from years to days, maybe you had to go first to weeks and then from weeks to years or something like that, then you would just have an extra little ratio here. Okay? And you'll get to practice that a little right here in the practice. So the video is over now. You can go ahead and put your headphones away and go sit at a table or wherever you're comfortable and get to work on some of these practice problems. Some of them are going to be using the stuff that was on page 3, some of it from page 4. If you have any questions, please come over and raise your hand and ask, or just let us know that we can help.